Alright, so you want to figure out and understand RS and easy nomenclature. To me, RS is a little bit more difficult than EZ. I don't know why, it just is. So first we'll consider the RS nomenclature, right? So the first, I'll write a couple steps out so you could figure out the best way to go about naming compounds. So the first thing you want to do, so number one is locate your chirality center. Hopefully I'm spelling that right. Chirality center. Alright, and this is your carbon with 4 different groups attached to it. Alright. The second thing you want to do is I'll put centers right here because it can be more than one. The second thing you want to do is assign the relative priority. So what that means is based off of atomic number, you want to number your elements based off of atomic number size, right? So I'll put assign relative priorities. Alright. And finally, what you want to do is I'll put draw your circle. Draw your circle from lowest to highest. Alright. Highest number. And your circle can look like this, or it can look like this. Alright. And counterclockwise, which is this one right here, this would be called S, and clockwise would be called R. Alright. So we're going to use these 3 steps to figure out R and S nomenclature for a couple compounds, okay? Molecules, compounds. Alright, so the first molecule we'll deduce is chlorofluoroiodomethane. Alright, so that's the first molecule we'll talk about. Alright. Hopefully after watching this video you'll get a better understanding of how to determine if it's R or S. Alright. And then we'll move on to easy. But here I will draw actually I'll write the name down. So chlorofluoroiodomethane. Alright, so I'll draw that for you. Alright. We'll have going out and coming at us. Alright, so now I'm going to place my items. Here I have iodine down there, and right here I have my chlorine, and my hydrogen will be going back in the plane of the field. And lastly but not least, we'll have my fluorine. Alright, so now what do? We locate our chirality center. Here we only have one, which is right here. Right? You have a carbon attached to 4 different elements. So now what you would want to do is assign priority numbers based off of atomic number. So we know our iodine would be number 1, our chlorine would be number 2, fluorine would be number 3, and hydrogen would be number 4. And actually I'm going to switch these 2 around. So I'll switch these 2 around. I'll have my hydrogen coming at me, and I'll have my fluorine going back. Alright, fluorine. 3, so I'll have to change these numbers as well. So we have 4, we have 4 and 3. Alright, so the next step after that is draw your circle from lowest to highest. So we have 1, 2, 3, 4. Alright, so that's what you want to do. So this is going counterclockwise, so this will be called S, but not really. Okay, so we notice that our lowest priority group, which is hydrogen, is coming out at us. And remember that we want our lowest priority group to be going back in the plane of the field. So because it is coming out at us, we can't name it S. All right, we will call it R. All right, so we will call it R. So usually what I like to think of is if the lowest priority group is coming out at me, I flip the letter. So for example, this hydrogen, like I was saying, is coming out at us, so we can't call it S, and I flip the letter to R. All right, so this would be R chlorofluoroiodomethane. Hopefully that makes sense. So whatever your lowest priority group is doing, you can either designate it R or designate it S, but because the lowest priority is coming out at me and my arrow is counterclockwise, I would flip the letter to R and not S. So same thing if this was R configuration, I would flip the sign to S, but in this case it's S, so I flip it to R. Alright, so hopefully that makes sense. And the R molecule of chlorofluoroiodomethane looks like this. So it will look like this. I'll draw this. So just in case you're asked to draw R chlorofluoroiodomethane, which I doubt, but you never know. So your fluorine will be here. Your chlorine will be here. Your lowest priority group hydrogen will be going in the back of the field, and your iodine stays at the bottom. Alright, so this is the correct form for R chlorofluoroiodomethane. Alright, so hopefully that makes sense. I'll do S nomenclature so you could get a better idea of what I was talking about flipping the sign, when you would flip it, and when you would not flip it. Alright, so I'll go over that real quick. So go over that really quick, and then we'll go over easy nomenclature, which I think is a little bit easier. Alright, so I'm going to draw the compound cyclohex-2-enol. Alright, so cyclohex-2-enol. Alright, so I'm going to draw that right here. And we have my OH group, and we have our hydrogen. Alright, so we have hydrogen and OH. Alright, so again, first step is you want to locate your chirality center or centers, and here we have just one right there. Alright, second thing you want to do is number. So we have 1 based off of atomic number, 1, 2, 3, and 4. Next thing you want to do is draw your circle. So from lowest to highest, so we have, looks something like that. Alright, so now what you want to do is you want to look at your lowest priority group and see if it is behind or going back in the plane of the field, which it is. Our hydrogen is going back in the plane of the field, so we designate this one S because our lowest priority group is going in the back of the plane of the field. So hopefully that makes sense. If not, you can watch the video over or comment in the comment box for better understanding. So now we can move on to EZ nomenclature, which, like I said before, I feel like is a little bit easier to understand. EZ nomenclature because it is easier. Alright, so here we go. So EZ nomenclature. Alright, so this is a little bit easier, like I like to reiterate. So what you want to do, and this EZ nomenclature is only used for alkenes. Alright, so try to remember that it's only used, so I'll write that here, only used for alkenes. Alright, alkenes. So remember that. So that's one way not to get confused when you're doing RS and EZ. The EZ is usually or always used for alkenes. Alright, so what I will do is give you an example of the Z form of butene. Alright, so we're going to talk about butene. Alright, so here we go. Butene. So I'll write that down right here. Butene. Alright, so again, this has steps to it as well. Not as many steps. You could think of, I know some people say that it's not the same, but when I look at it, it's the same to me. So take it with a grain of salt, or you could take it for what it is. So the Z to me, I feel like is cis, and the E I feel like is trans. And this has to do with double bonds. So remember that this has to do with double bonds. Alright. So what we're going to do is draw 2-butene. So what I have here is that, and I'll have my hydrogens. I'll draw in my hydrogens to make life a little bit easier for you. So here's a hydrogen, and here is my CH3 and CH3. So we're going to deduce this structure here. So basically, because my priority groups, or my relative priority groups based off atomic number, which is CH3 and CH3, is on the same side of the double bond. You see the double bond here. So these groups here are on the same side, as you can see. Alright, and you could draw a dotted line down here for symmetry, and you can see that it's symmetrical. You have CH3, CH3, OH, or I'm sorry, hydrogen and hydrogen. So the two highest priority groups are on the same side of the double bond. So we would call this Z. Okay, we would call it Z butene. Alright, so try to think of it based off of symmetry and based off of what side the highest priority groups are on. Alright, so try to think of it that way. So the next thing we'll consider is we'll consider butene again, but we'll look at it on the E side, okay, on the trans side. And again, the cis and the trans helps me remember what Z and E pertain to. They don't have any relationship to each other, but it just helps me remember a little bit better. All right, so I'm going to draw it like this. I'll have CH3 here, CH3 here, hydrogen and hydrogen. So as you can see here, our highest priority groups are on different sides, okay? Different sides of the double bond, so they aren't symmetric. All right, so this would be E, because they're on different sides of the double bond. All right, they're on different sides. So try to look at the molecule and see what side your highest priority groups are on. If they're on the same side, then it will be Z nomenclature. If they're on opposite sides, it will be E nomenclature. And you can actually take out, let's say this right here was a fluorine or something random. Let's say this was a fluorine. Let's say this was a fluorine. Alright, so you see the highest priority groups would be fluorine and CH3, and they're still on the same side. Alright, so you would still name that Z, and let's do the same thing over here. Let's say this is a fluorine, and you would still name that E, okay? You would still name that E. So hopefully that makes a little bit of sense for you. Like I said, if you have any questions, you could post it in the comment box and I'll get back to you as soon as possible. Alright, but hopefully the EZ and RS nomenclature makes a little bit more sense for you.